Okay, so hi everyone. Let's get this started. Welcome to the second recitation of CS 2100. So I'll make a bunch of announcements first, and then I'll pause to see if you have any questions, and I'm sure there will be some. And then we'll talk about, do a couple of examples on predicate implications and hopefully basic proofs. So that's our plan for today. Okay, so first of all, homework 1 is due this Friday at midnight, so 11:59 p.m. this Friday. Then next week we have our first quiz, so it will be on Tuesday, September 8th. Please read the rules about the quiz on Canvas. But in short, you have a time window between 7:30 a.m. and 4 p.m. when you can start your quiz. And once you start it, you have 1 hour to submit it. So you should probably not start it after 3 p.m. because then your 1 hour window will be shorter because you have to submit it by 4 p.m. In preparation for the quiz, TAs will offer quiz 1 review sessions. There is a bunch of them, a few of them on Friday, and also one of them on Monday. So Monday is a holiday. However, we will still hold one review session in case you guys want to practice for quiz 1 just before you do it on Tuesday. Apart from these special sessions for quiz 1 review, also there are other office hours today, tomorrow, and Thursday to which you can come to ask questions about any kind of problems you might have and so on. So these quiz 1 review sessions are not replacing office hours tomorrow, today, and on Thursday. We also posted quiz practice 1, quiz 1 practice quiz on Canvas. And so I strongly suggest that you go through that quiz, try to solve it on your own, make sure you understand it. It will greatly help you to do well on the actual quiz 1. As promised, we also set up quiz 0, which will be open tomorrow, and we made an announcement about that. And the purpose of this quiz is for you to make sure that your home setup for submitting exams works. And also it allows you to read the pledge and quiz rules so that you are ready for quiz 1. So the pledge and the rules will be the same. And so make sure to read them during quiz 0 so that you are ready for quiz 1. This quiz will not be graded, and read the Canvas announcement to learn how to actually do it. And make sure to do it because during the actual quiz, we won't accept excuses about, I didn't know how to submit it and so on. You have this quiz 0 to practice that. I also want to stress out that on the day of the quiz, so next Tuesday, there'll be no recitations, which means that basically you can solve your quiz during your recitation slot, but that's not required. You can do it anytime between 7:30 a.m. and you have to submit it before 4 p.m. And during every exam, you're allowed to have an index card, which is 1 letter-sized paper, and you have to submit it together with your quiz. So you have to scan it and submit it together with your quiz. Okay, about the regrading policy. The main thing to remember is that you have 1 week after you receive your score to submit your regrade request. So make sure to do it as soon as possible after you get your score. After that, we will not be accepting regrading requests anymore. Regrading requests for quizzes, homeworks, and the final are done through GradeScope, which has a regrade functionality. For problem sets, you should submit your regrading request through Piazza, and there was a Canvas announcement about that. To prepare for quiz 1, please utilize the office hours, the quiz review sessions, and Piazza as well to ask questions. And so you should also make sure to read the syllabus and to read the pages related to cheating and the rules for taking quizzes and so on. There is much more information there on Canvas than what I can squeeze into, these short announcements. I just pulled out what I think is the most important ones here. But you should, of course, still make sure to read everything else on Canvas as well. So one more important thing is that you must match questions to pages in Gradescope to be eligible for full credit. So when you're submitting your solutions through Gradescope, you will have to say, this page is my answer to question 1, this page question 2, and so on. And Gradescope provides this functionality. If you don't do that, you will not get points for your quiz. So don't forget to do that. This also means, as is described in our quiz rules, that every question has to be answered on its own page. So don't write down solutions for more than one question per page. And then you can have this index card on a sheet of paper. So 2 pages, just 1 sheet. And you have to submit these index cards with your solution as well. And you will have to sign this pledge as well. There was a question about needing to have a printer. You don't need to have a printer. You can solve your quiz on empty sheets of 8.5 by 11 paper. And you can scan these sheets. And you just have to match in Gradescope your solutions to questions. The same goes for the pledge. You don't have to print it out. If you don't have a printer, take an empty sheet of paper and simply write down, I read the pledge and I'm acknowledging it by signing it here. And then you sign this sheet of paper and you scan it in. So you don't need a printer to be able to submit your quiz solutions. Okay, these are my announcements. So before I move to solving problems, are there any questions? Okay. Wow. I am almost shocked that there are no questions. In the previous recitation, I got like 50 questions.
Oh, there is a question from the chat. Can we take pictures if we don't have a scanner?
Yes. So again, tomorrow you have this quiz 0. It's not graded, but allows you to practice submitting quizzes. And so if you don't have a scanner, you can do it using your phone. To be able to use your phone to do this, the best way to do it is to install a small app that basically serves as a scanner. So it allows you to use your camera to load in your solutions as a PDF and then to submit them through Gradescope. And this is all explained on Canvas. And there is a link to a document that shows this application and how to install it on different kinds of phones, Android and iPhone and so on. So make sure to go through this. And tomorrow, definitely start quiz 0 and actually try it for real, right? So make sure that you can submit quiz 0 properly. Good question. Any other questions? Okay. Let's try to solve a couple of problems. Yes.
There is another question from the chat. If we have an iPad, we cannot use it for the quiz. So we can we use the pad in the quiz?
Yeah. So that's a great question. And for some weird reason, I cannot open the chat window. But that's okay. So yeah, I got the same question last time. So yes, so there are a couple of different ways to actually, solve the quiz and submit it. One of them I described. You use pen and paper, and then you scan it in, either using a scanner or your phone. If you have a tablet or some kind of device that allows you to write on PDFs, you can use that as well to solve the quiz. And then you can directly submit these PDFs. So that's totally fine as well. Finally, you can also use Word and LaTeX templates that we're going to provide. If you're kind of brave and comfortable enough to write mathematics using LaTeX or Word. So that's another option. You can also do something like, again, if you can write on the screen, you can use something like Adobe Acrobat to solve the quiz as well by writing directly into PDF. So all of these work. Any other questions?
Oh, there are 2 more questions.
Okay.
Can the index card be created digitally like PDF, or does it need to be physically sheet of the paper?
No, you can create it digitally. And again, look at the rules for the index card. We don't allow tiny fonts, for example. You know, if you want to use like font 4 to squeeze like 20 pages of text on the index card, we don't allow that. But it can be a digital index card. The same as pen and paper card, you have to then submit this PDF with your quiz, but it can be digital.
Another question. When we submit the index card, do we need to match each question to it, or just submit once?
No, you submit the index card just once. So index card will not have questions or solutions on it, right? It will just be, you know, like things for you to remind to help you with the quiz. You should not be writing. So sorry, you should not be writing questions and solutions in your index card. You should be writing things like, you know, rules for implications and so on, right? Another question, I'm confused about the last bullet point. It allows for an 8x11 sheet of paper, but then says no pieces of paper afterwards. Sorry, maybe this is a little bit confusing. What we meant is you cannot have like random tiny pieces of paper, like Post-it notes or something like that. So your index card has to be one 8x11 sheet of paper. That's the only thing that is allowed. So what I'm trying to say here is that your index card should not be, you know, 10 Post-it notes. Any other questions? Okay. Yep, front and back of a sheet of paper. So one sheet of paper, 2 pages, front and back. Yes. That's a cheat sheet. That's another name for index card. And all of this is also on Canvas and more. So make sure to read the rules on Canvas. Another great question by Caleb. Do we need to video ourselves taking the test? No. So we are not going to use ProctorU. You don't have to video yourself or anything like that. So we are not going to be monitoring you like that. I kind of think that's a little bit creepy, and so we are not going to do it. And so what was I going to say? But you will have to sign the pledge and, you know, read the rules for cheating. Of course, you should not be communicating with anybody else. You know, you should be alone in the room. The only thing that is allowed is the index card and, you know, a couple of sheets of paper where you're going to write down your solutions. You should not be going online to find solutions and so on. You can ask questions on Piazza, so that's allowed. So we will be monitoring Piazza during the quiz, and you can ask questions there. Next question, can we have scratch paper? And Adriana is asking that. So, I mean, the questions are not super extensive. You don't have to write like 5 pages of text to solve them. So you should not have scratch paper, and whatever you do write on, you should scan it in with your solutions. Okay, so there's the question about scratch paper. So anything you write, you should scan in and submit with your solutions. Next question, can we note some rules like commutative or distributive on the index card? Yes, that is the purpose of the index card. So you should know these rules on the index card. And then Alex is pointing out there might be some confusion about cheat sheet and index card. So I'm sorry about that. So when we say index card, we mean cheat sheet. We use the two interchangeably, and so and it's a normal sheet of paper and not a smaller card. So I hope that clarifies it. Next question by Haley: is there a time limit for the test? Yes, it's 1 hour. So once you open the test, you have 1 hour to submit it. But the time window when you can open it is between 7:30 a.m. and 4 p.m. So it means you should start it before 3 p.m. because you have to submit it by 4 p.m. And you cannot pause time. Time starts once you open it, and then you have 1 hour. So there is no way to pause it and get back to it. Any other quick questions? Okay, so there was a lot of questions. I tried to hit the main points in my announcements, but please make sure to read the syllabus and the pages related to it. So rules about cheating, rules about index card, rules about submitting quizzes, and so on. Make sure to read them and to understand them, because there is much more there than what I just said. Okay, let's now move to solving some of our problems. Okay, so here's the first one. I'll give you a minute or two to solve it on your own, and then I'll solve it for you in the slide. And so the material that will be in quiz 1 is everything up to proofs. So proofs will not be in quiz 1. So logic, quantifiers, truth tables, using those rules to prove equivalence, things like that can all be in quiz 1. And so this is the kind of question that we're solving right now that might be in quiz 1. Okay, so we want to write these statements using quantifiers and logic notation. For every integer x, x squared plus 1 is positive, and there is an integer n such that 2 to the power of n is equal to 32. So we want to write these two statements using quantifiers. So please try to do this on your own, and then I'll solve it for you in a minute or two.
Professor, here is a question. So lecture 1, 2, 3, 4 will be in quiz 1. Is this right?
I have to remember a little bit. Did lecture 4 already have proofs? I think lecture 4 already has proofs. I'll make an announcement about that. I think lecture 4 already has basic proofs. So I think lectures 1 to 3 will be in the quiz, but I'll make an announcement about that. Okay, let me set my pen. And let's solve this. So let's do the first one first. For every integer x, as soon as you see for all, you know you have to use this symbol for all x, and x is an integer. Don't forget that you always need that. Then we put the comma such that x squared plus 1 is positive, meaning greater than 0. So this is the formula for the first statement. And then for the second one, we have there is an integer. So there exists an integer. There exists an integer x. Oh, sorry, it's n in this case. Let me fix this. So there is an integer n. Don't forget, you have to denote that n is an element of z, which means an integer, such that 2 to the power of n is equal to 32. So these are the two logical statements describing these English statements. Any questions about this?
Yes. What does that Z symbol represent?
So Z, and you write it like this. You should look it up in your textbooks. So that is the set of integers. So this Z represents set of all integers. So that's a common symbol that we'll use throughout this class to represent the set of all integers. You also have R, like this, that represents the set of all reals, and then Q, kind of like this, which represents the set of all rationals. Any other questions? So you should know these symbols for these sets, and I think we did have them in the lectures as well, and they're definitely in your textbooks. Okay, if there are no other questions, let's do a little bit harder problem that involves quantifiers and negation. And again, you should know how to negate quantified formulas. So we have these two statements here. First, we want to write out these statements using quantifiers and symbols of the logic. And then we're going to negate these statements. And then we should see whether they're true or not. And then I'll solve one of them for you. So I'll give you a couple of minutes to work on this. One hint here. You have to use implication to express these statements. So you'll need the application operator to be able to do it properly. And another thing I just noticed, in statement 1, we are not saying to which set X belongs to. And by default, we are going to assume that X is an element of reals. Sorry. In the quiz, we'll always specify it. Here it's a little bit underspecified. But if it's not listed, then we assume that it's an element of reals. Okay, so I'll give you 1 more minute, and then I'll do the second one with you. I did the first one in the previous recitation. We make all the videos available, so you can look up, and I'll make all the scribbles available for both of them. So you'll be able to look up how to solve the first one as well. But in the interest of time, I'll just do the second one for you. Okay. So let's do the second one. So let me just see the question. Is there a question? So the question is during a different section. Right. So I solved the first part of this question in the recitation for section 22. And we make all videos for all recitations available on YouTube. So you can look it up. And also, I'll solve it and I'll post the solutions online as PDF as well. So you'll be able to find it there as well. Okay, so what do we have? There exists. Sorry about this. Let me go back. There exists a negative integer n. So there exists n that is an integer. So don't forget, you always have to specify which set it belongs to. In this case, it's an integer. And now this integer is negative. So we have n less than 0 implies 4n plus 2 is greater than 1. So this is the cleanest way of writing this. So there exists an integer such that n less than 0 implies 4n plus 2 is greater than 1. So that's how you would write this sentence as a formula.
Oh, there is a question. Can you not just put a little negative signal by the z to show that n is an integer, a negative integer?
Yeah, so that would be another way of doing it. Then when you are negating it, you have to be careful how you negate that. I find it easier to write it down like this because then I find it easier to negate it. So yeah. Good question, though. Okay. So now the next step is to negate this. So let me do that. So we want to negate this whole thing. So we have not n element of z such that n less than 0 implies 4n plus 2 greater than 1. Okay, so let's negate this. So that's equivalent to we have to know how to negate the exists. So if you remember the rule, negation of there exists x such that some formula f is equivalent to for all x not f. So we push the negation in. We didn't say this in this problem, but typically when we're solving these problems, we're always asking you to push the negation in as far right as you can. And in particular, you cannot have negation in front of parentheses. So let's do this. We get for all n element of z. And then we have negation of this whole thing. So that's equivalent to for all n element of z such that now we have to know how to negate implication. So that's again one rule that is in your textbooks and that you should know. So negation of P implies Q is equivalent to P and not Q. So we have n less than 0 and not 4n plus 2 greater than 1. So that's equivalent to for all n element of z, n less than 0, and we have to push this negation in, and we get 4n plus 2 is less than or equal to 1. So there's the negation of this statement. Any questions about this? Okay, I can take a look at the chat. Does n need to be bigger than or equal to 0? That's a good question. So look, so up there, I wrote, sorry, up there, I wrote the rule for negating implication. So negation of P implies Q is equivalent to P and not Q. So we don't have to negate the left-hand side. So we don't have to negate n less than 0. That stays the same. And we only have to negate Q. Any other questions? Okay.
Oh, there's a non-question in the chat.
Okay, so Owen is asking another question. When we negate the implication symbol, do we always change it to the n symbol? What if we negate the n symbol? Does it become the implication symbol? Yeah, so that's a good question. Not quite. If you negate the n symbol, usually you get the or symbol. Unless you are really in the form that matches the implication. So you don't really move directly between and implication. Only in the case of negating it. So actually, in the next example, we'll see what the negation of and or are. I'm curious to see how this problem will be solved using the z minus notation. That's a good question. Let me. So in the interest of time, we'll have to move ahead. But in my notes, I will solve it using z minus notation as well. So I'll make it available. Any other questions? Okay. Okay. So let's move ahead then. I want to move ahead because I definitely want to solve the next problem with you guys. Okay. So let's do one of these proving logical equivalence using theorem 2 problem. Except that this one has a little twist because it includes implication. And if you look at the theorem 2 rules below, you will see that none of them include implication. So what does it mean? You should know the rules for implication and the properties of implication basically by heart. You should know them, and they're in your books, and we also cover them in the lectures. So I'll give you a couple of minutes to do this on your own, but I'll give you a hint here. So to prove equivalence, you have to rewrite one side of this equivalence into the other. And usually, we want to rewrite the left-hand side into the right one. And so if we look at this a little bit, we can see that the left-hand side and the right-hand side are pretty similar, except they're kind of a little bit flipped, right? On the left-hand side, we have P and Q on the left of this implication, while on the right-hand side, we have them on the right. So the first step we probably want to do is to switch the order of the implication of the left-hand side. And we should know the rule that does this for us. So that's the contrapositive rule. We know that P implies Q is equivalent to not Q implies not P. So as a hint, we should start with this rule first. And then we should take it from there. And so let me do this first step for you. So the left-hand side will become, when we apply the rule, we have not Q, so not R or not S implies not P and Q. So this is a good first step because now we are getting closer to the right-hand side. So once you do that, you can now actually start applying the rules of theorem 2 to work on this to get into the format of the right-hand side. So I'll give you maybe a minute or two to try applying theorem 2 rules to this. You always have to denote which rule you're applying, and then I'll solve it for you and we'll go through it. Okay, so try to do it on your own first. Okay, let's do this. So what do we see first? Okay, so on the left we have negation of a parenthesis where we have or, and we can apply this De Morgan's law here. And that's what I was mentioning last time. The negation of or is usually and, negation of and is or. So let's do this. So we have De Morgan. I'll just write DM to make it a little bit faster. And we get not R and not S implies not P and Q. Wonderful. Now we have this not R, which is double negative rule. So let's do double negative. So when you're solving this in the quiz or in the homework, spell out these rules completely. In the interest of time, I'm kind of shorthanding them here. So we apply double negative once. We get R and not S implies not P and Q. Okay, let's do another double negative to get rid of these two negations on S. And so we get R and S implies not P and Q. Oh, wonderful. Okay, so we're close. The only thing that we still have to do is apply another De Morgan to push this negation into this parenthesis. So we do another De Morgan, and we get R and S implies not P or not Q. And what we got here is the same as the right-hand side, and therefore we prove this equivalence. Note how I applied the double negative rule. So I didn't do R and S at once. So make sure that you apply the rule. You only apply it to one thing, and you do it in this like really canonical steps. Okay, any questions about this? So in the quiz, you absolutely need to write down every step, including the rule that you applied. And also when you apply the rule, you apply it to only one thing, like I did here. So first apply double negative to R and then to S. So don't just write the final answer. We are looking for every single step, and you will lose points if you skip steps. Any other questions? So the follow-up question, so I need to write down what method that we used for the answer. You have to write each rule as you are applying them. Yes. Okay. Let's move along. Let's maybe try to do a simple proof. And I'm going to, we'll do this a little bit differently. I'm going to put you into breakout rooms, and you can get to know a couple of your peers and you can discuss your solution. And then in 3 minutes, we'll come back and then I'll quickly solve it for you. So let's do breakout rooms. Okay. You'll have to accept to be placed into a breakout room. So please do that. There should be around 3-4 students per room, and you'll get a chance to discuss this proof. Know that this is a pretty simple one, right? It's a direct proof. N is even, so you should write down what it means. And then you have to prove that n plus 8 is even.
Hi, Professor.
Yes.
There is a notation that the host moves us to the breakout room just now, so there are only 5 students in this room now.
Right. So they're in breakout rooms.
Okay.
Yeah, we'll close the rooms soon, and then they'll come back. Okay, welcome back, everyone. I hope this was fun. Sorry for going a little bit over time. So let's quickly solve this. So we know that n is even. So that means that n is equal to 2 times m, where m is some integer. So that's the definition of even. Then we want to prove that n plus 8 is even. So let's use this fact, and we get that n plus 8 is equal to 2 times m plus 8. Great. So we have this n plus 8 here. We want to show that this is even. So let's try to show that the right-hand side is even. So we get 2 times m plus 4. This is simple algebra, and that is equal to 2 times k, where k is equal, k is also an integer. And we did this substitution, and we can do it because of closure of plus. So what do we have now? We have that m plus 8 is equal to 2 times k. And from that, it follows that n plus 8 is even. And that finishes this proof. I like to finish my proofs with QED. I do proofs during my research, so I'm kind of used to it. You don't have to do it, but it is a nice thing to do. Any quick questions about this proof before we wrap this recitation up?
Yeah, I have one question. For the last step,
cool.
wouldn't you have to specify for the last step that integers are closed under multiplication?
For the last step. No, this is just the definition of even. So here,
right. Okay.
you don't have to.
Yeah,
Yeah,
that makes sense.
Yeah.
I missed
Good
that.
question, though. Yeah. Any other question?
Yeah. What did you do? Like on the fourth line to the right, what does that say? Closure of plus. What does that exactly mean?
Fourth line, which one? Closure of plus?
Yeah.
Oh, so I'm substituting m plus 4 with another integer k. And I can do this because I know that m plus 4 is also an integer. And I know that m plus 4 is also an integer because integers are closed under addition.
Okay.
And Q and D, I actually have to look up what it means. It's Latin. I have to look up what it means. So I'll look this up. You don't have to write QED. It's just something I like doing to finish the proof. It's a common way that mathematicians use to finish their proofs.
So do we need to write down like closure of plus in the exam? Yeah, I mean in the quiz?
Yes, you have to write down closure of plus in the quiz. So you have to write down which properties you're using. And the other question in the chat is it okay to use any variables on the quiz as long as we don't repeat them? Yes. So you don't have to use M and K. You can use, A and B. That's totally fine. Okay, I'm sorry, we really have to finish now. We are going over time and Bay has to start her next recitation. So we'll wrap it up here. I'll post the video, of course, and also the notes. I'll clean them up and they'll be under our scribbles. And we'll wrap it up now. So thank you all for joining. And goodbye, everyone.
Thank you so much.
Bye.